Well, hello everyone. Today I have a brushed DC motor controller and I want to make a teardown of it and explain how it works. But first I must say the video uploads will be a bit on and off for the foreseeable future because I have some exams coming up. But when I have time I'll record. So anyways, back to this. This is usually used for e-bikes with brushed motors, more of the DIY kind. This is the motor output, this is the power in, and this is the throttle or speed adjustment. And there's also a few other things like ignition, stop, and brakes and everything. But let's open it up. And let's see. Should I show off how it works? I'll show it after I open it up. It has a aluminum casing. Aluminum. What do I know? And from this screw, I can assume it uses the actual casing as cooling for probably MOSFETs. I doubt they're using BJTs for this. Pretty inefficient. And here is the back, and it's awfully empty inside. I do see some ICs. Alright, let's see how it ticks. Is this supposed to be waterproof? It doesn't seem to be so. I don't think it's supposed to be waterproof. I think I also need to take this one off. Alright, does it just slide out? Thermal pads. And this is just empty now. Is that a current shunt? I think so. Why does it have a current shunt? Why? It's also awfully empty in here. Come on. Are these glued? No. They're just stuck. And it's just a single IC, which seems to be Texas Instruments. It's an LM339. I think that's a comparator actually. Is it? I can't remember. I know it's from the LM lineup with op-amps and everything. How is it simple? I see another set of MOSFETs which are probably used here. Let me get a pointing stick. I need pointing. Where is my pointing stick? Ah, found it. I say pointing stick, but it's actually a pair of ceramic tweezers. Anyways, so this is on LM339, which I'll probably put a datasheet up on screen. And I assume these two are just MOSFETs, very small ones for probably turning on the whole circuit and turning on the brake lights, as it has that feature. It has a pretty beefy capacitor, 470 microfarads at 50 volts. This is supposed to operate at 24, I believe. It's supposed to be written, yeah, 24 volts, 22 amps, 21 plus minus. I don't know what this is supposed to be, and I also don't know this. I didn't learn Chinese. Yun Tech. Alright. I don't know what this is supposed to be. It's just an empty connection. We have some diodes on what I think it's, yep, throttle. Some resistors on what I think those are the brake lights. And the ground. Alright, what I see are these RU6888R. I'll also probably put a datasheet of these on screen. I'm still wondering why there's a current shunt on this. I don't think they need it for anything. I mean, on the back there's just some big ground planes. Do I have a better pointing stick? Fine, use one of these. So this is the main ground. This is plus, which goes, this is the capacitor, and it goes straight through, so there's no switching for the plus. This is the current shunt, which goes between here and everywhere else. Great, butterfingers. And the output is the negative, so I would assume it's N-type MOSFETs. Are they both the same? Why are there two of them actually? No, they're not the same. Hold on. STPS 2045 CF. Are they not in parallel? I mean, maybe one of them is a voltage regulator, but it's connected to the output, so I don't know what that's supposed to do. Well, let's power it up, I guess. There's not much inside, so at least maybe we'll see some cool waveforms on the oscilloscope. And I forgot to set the PC to record it, so we're gonna have to deal with just putting it down here. Alright, let's see. Plus, minus. Let's set it up. 24 volts. 26. Should be in range. Now let's get a probe. Let's see, can I shove this one in here? There. And now I just need to remember which one is the anything here. I need to short one of these, I don't know which one. So we're about to find out. I think this one. Come on. Just stay in there. Alright, let me get another. Don't do this. Like, don't do this like ever. I'm only doing it because it's 24 volts and I have an amp limit. .5 amps. Let's see. Anything else I can short? Oh, I know. I'll just do this. Come on. There we go. And I'll go. Which one is the output? No. This one? Ah, yep, this one. Alright, let's get you. Good. Let me. There. Let me actually get a throttle. Stay there. Alright. E-bike throttle. Let's hook it up and see what we're getting. I probably need to go Sport Division. Am I do something? Why? I'm supposed to see a duty cycle. Hold on. Let me put this in here. I hope these are the keys. Nope. Are these the keys? No? Come on! Ah, there we go. It also has a cool little display. You know what? I think I need an actual load. No problem. I have a little DC motor around here. There we go. I probably shouldn't be doing this without cooling, but whatever. Let's see. Hey, there we go. Can I auto? No. I want to see the duty cycle. And yup, It's just a PWM controller. That was my power supply cutting off from the power limit. Are you getting hot? No? Good. So yeah, these are basically just PWM controllers. My question is, how low can they go, voltage wise? Let's try 12 volts, because then they might actually be useful. Nope. So yeah, 24 volt only. I'm pretty sure you can get them in 12 volt, but I guess this is about it. Let's try it back together. So yeah, it's a pretty simple circuit. I probably should take a photo of it. I mean, let's just free up this thing before so come on, move out the way. You can find this for about, I don't know, let's say 20 bucks, one of these. If you need it, I mean, you need it. A whole kit maybe like 30. Come on. So it's a very simple circuit actually. It's probably just an op amp that amplifies something. I doubt this is an actual speed controller. I see. It's probably just a simple circuit which generates a PWM and uses that signal to activate two MOSFETs. Usually you'll find these made with 555 timers, because they're also pretty good at doing this, but probably this is more stable. As we saw, the frequency doesn't change, and any 555s can actually change their frequency. So probably just a self-oscillating circuit with PWM output. Very cheaply made. Very. I don't trust these wires for 20 amps. Anyways, this was a quick video I wanted to make to, you know, start a teardown series, as I would like to call it. I seriously enjoy tearing stuff down and explaining how they work. And this was a bike motor controller. Again, for the foreseeable future, uploads will be on and off because exams, but you know, I'll try to record when I have time. See ya!